evaluate the following triple integral. So looking at the bounds of our triple integral here, we notice that both the inner integral and the outer integral have bounds that are functions. So the order of integration here that's given to us will be crucial. So we cannot separate this out into three individual pieces here because the following integrals depend on the previous integral's evaluation. So to get started, we want to evaluate the inner integral, which here is dx. So we're going to start right off. We want to pull out and evaluate the inner integral. So this is the integral from the natural log of 5y to the natural log of 6y of the natural exponential raised to the x plus y squared minus z dx. And if it helps you in evaluating this using properties of exponents, we can rewrite the integrand and think about this as the natural log from 5y, the natural log of 5y to the natural log of 6y of the natural exponential raised to the x multiplied by the natural exponential raised to the y squared minus z dx. And so since we're holding y and z as constants here, we can pull those right out in front of the integral. So I have the natural exponential raised to the y squared minus z multiplied by the integral from the natural log of 5y to the natural log of 6y times the natural exponential raised to the x dx. And now we have a general antiderivative, and this leaves us with the natural exponential raised to the y squared minus z out in front, multiplied by the natural exponential raised to the x by 1. And we're evaluating now from the natural log of 5y to the natural log of 6y. And so this is the natural exponential raised to the y squared minus z multiplied by the natural exponential raised to the natural log of 6y minus the natural exponential raised to the natural logarithm of 5y. And we know that the natural exponential and natural logarithm are inverses of each other, so they undo the effects of each other, leaving us with the natural exponential raised to the y squared minus z multiplied by 6y minus 5y. And this leaves us with just a y. So this is equal to the natural exponential raised to the y squared minus z multiplied by y. So this is the inner integral. And we now substitute this back into that given triple integral. And so this is now the integral from 1 to the natural log of 3 multiplied by that middle integral, which is 1 to the square root of z of the natural exponential raised to the y squared minus z multiplied by y dy dz. So we have reduced the triple integral to a double integral, and the next thing that we need to do is evaluate our middle integral. And so let's give ourselves plenty of room. So we're going to pull that out and evaluate the middle integral with respect to y. So this is the integral from 1 to the square root of z of the natural exponential raised to the y squared minus z times y dy. And so looking at this integral here, we realize that we're going to need to use u substitution. So I'm going to go ahead and let my u be y squared minus z. So differentiating with respect to y, I have du dy is equal to 2y, and z goes to 0. And then solving for dy here, we are left with du divided by 2y is equal to dy. And then we want to be careful here. The bounds that are given to us in this integral are with respect to y. So if we change the variable, we have to change the bounds. So the bounds that are given to us are y from 1 to the square root of z. And I want to change these to u. So thinking about the u that we defined above, we can say that that's u of y, which is defined by the function y squared minus z. And plugging each bound in, we have u of 1 is 1 minus z. And then we have u of the square root of z would be the square root of z squared minus z. So z minus z is equal to 0. And we can say the bounds that we'll use here with our u substitution are from 1 minus z to 0. So plugging everything back in here, this is equal to the integral from u of 1 to u of the square root of z. We have the natural exponential raised to the u multiplied by y, and we replace dy with du divided by 2 times y. And so we have nice simplification. We can see the y's cancel each other out. So I can pull this 1/2, this constant 1/2 out in front, and plugging in the bounds that we defined here for u, the u of 1 becomes 1 minus z, and u of the square root of z is 0. And the integrand is just the natural exponential raised to the u du, which is a general antiderivative. This integrates to 1/2 times the natural exponential raised to the u from 1 minus z to 0. So keeping that 1/2 on the outside, I have 1/2 times the natural exponential raised to the 0 minus the natural exponential raised to the 1 minus z. And we, of course, know that anything raised to the 0 is 1. And so we have the middle integral's final evaluation as 1/2 multiplied by 1 minus the natural exponential raised to the 1 minus z. And so we can now take this middle integral and substitute it back into the triple integral to evaluate the outer integral, which is with respect to z. So the outer integral bounds were from 1 to the natural log of 3, and the integrand now is 1/2 multiplied by 1 minus the natural exponential raised to the 1 minus z dz. And everything here is a general antiderivative. So this integrates to 1/2 multiplied by z minus the natural exponential raised to the 1 minus z divided by -1. And we evaluate from 1 to the natural log of 3. And we can simplify here before we evaluate. We can think of this as 1/2 multiplied by z plus that natural exponential raised to the 1 minus z from 1 to the natural log of 3. And let's make sure we give ourselves plenty of room. So keep again 1/2 on the outside. So plugging in the natural log of 3, we have the natural log of 3 plus the natural exponential raised to the 1 minus the natural log of 3 minus, and we plug 1 in. So this is 1 plus the natural exponential raised to the 1 minus 1. And we can simplify here. We know 1 minus 1 is 0, and anything raised to the 0 goes to 1. So this will be equal to 1/2 multiplied by the natural log of 3 plus the natural exponential raised to the 1 minus the natural log of 3 minus 1 plus 1 is 2. And so there's nothing wrong with this answer. We can leave it as it is. You could also distribute that 1/2 if you want and rewrite this as the natural log of 3 divided by 2 plus the natural exponential raised to the 1 minus the natural log of 3 divided by 2, and then 2 divided by 2 leaves us with that minus 1. So whichever way you prefer, they are both equivalent and correct. And this is our beautiful final answer.